record this. Hope you can see my screen and you can hear my voice, right? Okay, so this is the one we discussed in the last session. What is the difference between calculated column and measure? Okay, and the question is, when can I use the calculated column and when can I use measure? It depends on your use case. For example, I wanted to use a column in my slicer. I want to use a column. Okay, you cannot use a measure. There is a limitation with slicer. That is what I discussed at the time of explaining the limitations with slices, right? So you cannot use a measure in the slicer. Instead, you'll have to use a column. Listen, based on some column, I wanted to apply the filter to my visuals. In that case, right, you will have to have a calculated column. Listen, the existing columns are not helpful to do the slicing. So in that case, you need to create a new column, a derived column, or based on the existing column, you need to create a new column. So in that case, you can go for the calculated column. Okay. So again, both of them, measure and calculated column, both of them have its own plus side and downside. But we need to, so there is a trade-off. Yes, I have to, create a new column. Only then I can do the slicing of my data, right? So in that case, right, you'll have to go for calculated column. Like I said, if you use so many calculated columns, or if you use calculated column to solve, all kind of problems, right? So then you will end up with adding more number of columns, especially with the huge volume of data in a table. If you add more number of columns, it will consume too much of memory. Okay, it's a memory intensive one. So when to use a calculated column, use the value as a filter condition in a DAX query. In a DAX query, if you are using the value as a filter condition, the filter criterion, right? If you want to use a column, that kind of situation, you can go for that. Define an expression that is bound to the current row. Okay, and use the value in rows or columns of a pivot table. Okay, in that kind of situation, also calculated column, you can use it. Pivot table, here it is matrix. Okay, and use the value in a slicer. Okay, in this slicer, you want to use the column as a value. In that case, you need to use that one. Okay. Next one is the measure. So when should I use measure? Okay, the interview, you can expect this is the very commonly asked questions. So when will you use the calculated column? When will you use the measure? And what is the difference between these two? This is a very common question that you can expect in the interview. When do you use a measure? So okay, right. So if you wanted to make some selections, based on the selection that you make it in your slicer, you want the calculation to be changed dynamically. In that kind of situation, you can go for measure. Right, that's what I mentioned. Reflex uses selection of filters or slicer or highlighted visuals. Okay, so in that kind of situation, you can go for the measure. So what is a measure? Measure is a formula that will be evaluated in a context, right, in which it is used. The measure is evaluated in the context which it is used. Okay, for example, you have a measure in a matrix visual. That formula in your measure will be evaluated for each matrix row and column combination separately. Okay. So in the case of Power BI desktop, right, the measures helps us to perform calculations on your data as we interact with our reports. Okay, in that kind of situation also we use measures, and using which we can calculate the ratio and we can calculate a percentage. But in most of the time, we use measure to perform aggregation. Okay, aggregation, we will be, so when you perform aggregation, that kind of situation we'll be using it. But the measures will not live in your data set. As I explained or discussed in the previous session, it will not live in your data. That means once you create a measure, the values will not stored as part of your tables column. Okay, it will be calculated on the fly whenever you call this measure. but it can be used on other measures. You can use a measure in other measures. Okay, and okay, there are two types of measures. One is the implicit measure and explicit measure. Before we proceed with understanding what is implicit and explicit measure, okay, we will get started with in understanding the evaluation context. What is evaluation context? To understand and master DAX function, you need to understand the the evaluation context in DAX. Okay, this is very much important. Okay, to start with, let us understand at a basic level of the concept, and then we will proceed with taking a deep dive. Okay, so what is an evaluation context? This term is very specific to DAX in Power BI. So the evaluation context is nothing but the environment in which the DAX formula is evaluated. For example, you write a DAX function or formula, it will get evaluated within that environment. Okay, so in simple term, the evaluation context apply before the DAX formula evaluates. To make this bit clear, okay, the result, right, whatever the result returned by the DAX function can be different depending on the context. Depending on the context, the result returned by the DAX function is different, even if the DAX formula is same. See, in simple term, what is evaluation context? The environment in which the DAX formula is evaluated, or the scenario, right? The scenario in which the DAX formula is evaluated. You just think that way, okay? So I always start with this example. For example, so look here, okay, I just one second, please. I'm getting. Okay, see the okay, so okay, sorry, someone logged in mistakenly. Okay, so let's say I'm going to create a table here. One second, here, somebody. I'm getting a call. Just give me. Okay, so. So here I just clicked on a visual called the table visual. Okay, in this case, what I do is, look here in my data set, right? Sales W04. I have a column by the name of sales here. I just drop this here. Okay, look here. It shows the sum of sales value, right? It does the total on the overall sales. It did a total on the total. So look here, I just go to the data set here. Look here, you have a column by the name of sales here, right? In this column, what all the values are there, right? It took all the values and it did the sum. The entire data set, it did the total for the sales column. So how it is possible? Because in Power BI, right, if you look at any quantitative variable like profit, quantity, and sales, right? Just before this, you will find the sign, the sigma sign. For example, if I select the sales column, you can see that the data type of the column is decimal number. And then if you see the summarization, the default summarization is sum. Okay. When you drag and drop any numeric or quantitative variable into a visual, you will find the aggregated value. Okay, it will give you the aggregated. That's because of the default behavior. Okay, so this is the default way to summarize values in this column. Sum. If you want to change it, you can change it, but it is not advisable to change it here, the aggregation, type of aggregation, it is not advisable to change it there. Okay. It is not advisable to change it here. So in this case, what I did, I just put this value in this table. And then what we are doing is, right, we are seeing that the total sales for this. Okay. But when you look at this value, this number or this value itself, not interesting to us, right? Okay, it is not interesting. So that means, so with that, what am I going to do? So total sales, fine, right? I'm not interested in seeing the total sales. Is there any way if you can give me these split up or the breakup of the sales? Also, right? Can you give me the breakdown, sales breakdown? Okay. So in that case, what I do is I just move this somewhere here, and then I just copy paste this one, and I'm going to create one more thing here. Okay, first thing what I do is I just drag and drop. Okay, in this case, okay, let me do one thing. Ideally, I should have taken the other thing. Let me just see if I have the sales fact table. Okay, unfortunately, I don't have this one here. Okay, what I will do is, okay, this data is not much helpful. Sorry, I'll just move this to, I'll take something else. This is the data set. Instead of using the single file, we will use more than one file or more than one table, so that it will be good when I demonstrate the related table functions and all. Even in this case, the sales fact table, we have a column called sales. When you drag and drop the column sales here, it gives you the overall sales. Okay. And if you wanted to see the breakdown of the sales, you need to drag and drop the categorical variable or the column which has the categorical value in it. So here, okay, this is the one. I just give some meaningful name, sales fact. Some file was missing here. I don't know, mistakenly deleted it. Okay, what I will do is I just load the, all I need is the XLSX file. I'm looking for XLS file, BIM customer. I was using it, somehow I missed out here. I need to download it again. Anyhow, let me just select this one and see what happens now. Okay, and here, let me do one thing, XLSX, no. So I just remove this and then yeah, it's correct only. This is the one I'm looking for it. There are some small issues with the data here. What was, yeah, sales data, right? I have used this one. Yeah, this is, I just rename it as a dim customer table. This table, some issue is there, data formatting issues. I just go quickly here and then I will address it. I'll just go to the Power Query editor. Akka, Papa, Kuptuku. 1 second, sorry. Second, guys, sorry, some guests are waiting. Actually, sorry, guys, there is some confusion here. 1 second, here I just go here and use first row as it is, okay? Cat ID and category. So we are done. So, okay, my customer table is ready. And here I have C01. And if I select the sales factable, once again, yeah, customer ID is C001. Yeah, correct. So I just click on close and apply. I just loaded the data from dimension customer and sales fact table. Again, I did not notice this one. I thought it's a cust ID. That cat ID is there. Sorry. We need to rename the column. We need to give the proper name to this column. Here, this is not cat ID. This one's supposed to be customer ID. Let me just check here. Yeah. You need to follow the proper naming convention. Otherwise, also you can manually drag and drop it. But if the naming standard, like here, cust ID is the ID for the, okay, this is customer, but I can see, okay, something wrong here. Okay, I loaded the, okay, cat ID, right? This is correct only. There's a category. Actually, I wanted to load the customer. Okay, well, I don't know why it got loaded. Sorry, guys. Once again, let me just see. Dim category. Okay, let it be there, dim category. And sales fact, we have something called, do we have anything like cat ID? Okay, here it will not, you will get, because this one is linked with your product dimension. Let me do one thing. I don't know why this confusion. When I loaded the customer dimension, I should have checked the data here. I think mistakenly I loaded because of some disturbance. I got confused. This is correct only. Okay, this is the correct file. And use first row as it is. Okay, here I have the cust ID, and in the sales fact table, I have the cust ID, correct. So all the values are correct. And if I go to the Power Pivot thing, dream customer, the table name should not be like, the sheet one and all. Give some meaningful name, dream customer, okay. Fine, the previous one, I just renamed it, correct. So what happens, since the customer ID in both these table are same, look here, if you go here, cust ID is common in both the tables. It creates the relationship between these two tables. So this is a link, right? So one-to-many relationship. There is a one-to-many relationship between these two tables. Good. So now if I remove this one, and if I, instead of this, if I select the value from the sales fact table. Which one? The sales amount here. And I will, okay, I instead of dragging, right? So let me just copy paste this one. Okay, here, what I did, I just used the sales amount. I just dragged and dropped this here. Okay, but this is not the right way of using it, though it is displaying the total sales, right? It is a best practice to create a measure separately. For example, I just go and create a measure. How do I create a measure? So you can select the modeling tab ribbon, and then you can click on the new measure. This is one way of creating the measure. The other way of creating the measure is just next to the sales table, right? You have three dots here. This is called an ellipse, and you can select it, and then you can click on the new measure to create a new measure. Even this is not the best practice. What we do is in practice, we will create a separate table. We create a separate table wherein we keep all the measures, so that if you wanted to see all the measures later point in time, the real-time scenario will be creating more than 10 measures. Later point, once you create the measure, if you want to go and check what logic you have implemented during the time of testing or any code review, if you keep all the measures in a separate table, it will be good. Okay. But for the time being, what I do is I just select the modeling ribbon. I will show you how to create a separate table wherein you can keep all the measures. That one will show it little later. For the time being, what I do is I just select the modeling tab and new measure. Here, what I do is total sales. I just say total sales is equivalent to sum of sales. Sum of sales amount. Okay. I just hit enter. Instead of dragging and dropping this one, I'm going to use this measure. I thought of giving a demo with this one itself. Anyway, let's go by the best practice. Create a separate measure. Though the sales column in my data set or in my table can give me the total sales, but it is not the best practice in real-time scenario. Okay. To select the column itself. So what I do is I just type the total sales measure. Okay, this is my total sales measure. No, not this one. Already I have another one. Okay, this is the one I created just now. In both the table, I can see the total sales value as 4,56,148. Okay, fine, good. So this is the total sales, right? So then why should I have two visuals? Okay, here what I do is I just go and select the category column. Not the category column. I have used category, right? Okay. I have customer dimension table. I just dropped this here. So what happened? The moment when I dropped the customer name here, it is kind of the categorical value. The moment when I dropped it here, it shows me how much how much money spent by each customer. Okay, let me do one thing. I just best one is the category. Yeah, category. Best thing, I just use the category here. Okay. So earlier, when I dropped, initially what I did, I just created a measure. The first step, I created the measure. The measure name was total sales. So what logic I used it there? Look here, this is the one. Okay, ignore the other one. So here on the right side of the equal sign, I have used the sum function. Sum is a DAX function. Okay. Inside the sum function, I have selected the sales amount column that is available as part of my sales fact table. So it does the sum on the sales amount column, and then it stores the value here. The moment when you drag and drop it, it is not storing the value. Okay, the moment you drag and drop it here, what happens is it gives you the breakdown. Okay, in this case, okay, I don't know why that has gone here. Oh, the cat ID and cat ID. I need to select this one. Okay, here the cat ID is not linked. Again, look here, this is kind of a snowflake schema. Dim product table. You should load the dim product table. Only the product dimension table have a link with this one. Okay. I'll explain, don't worry. Okay. How many of you remember the snowflake schema? Okay, 1 second. Let me just. Okay, dim product is ready. Okay, and okay, now if you see here, okay, the moment when I loaded this table, dim product table, here what happened? These two tables, right? The category ID in this table and cat ID in this table got linked. It has a one-to-many relationship, and the product ID in this table is linked with this one. The category category dimension table is not directly linked with the fact table. It is not linked directly with the fact table. Okay, so in this case, what happens if you see here? Now it gives you the proper breakdown. So I have just so initially I did not use the product dimension table. Okay, because the category dimension table have no direct relationship with the sales fact table. Instead, it has to navigate. If you wanted to use a category dimension to filter this one, it has to navigate to the product dimension. It has to, it has to filter this table. It cannot directly filter this one. Okay, so because these two tables have a relationship, and only these two tables can get related. Okay, you can create the relationship. This is kind of a snowflake, right? So ideally, we should have kept these two data in these two tables information a single table. Okay, due to some design requirement, they want us to create some snowflake schema. So in this case, what happened? We have broken a single table into two different tables. One table is holding only the product table. Other table is holding only the category related information. But here, the cat ID column, we use a category ID column using which we link these two tables. Look here, if I keep the cursor over here, in both the table, cat ID and cat ID got highlighted. And if you hover the cursor here, product ID and product ID, these two table got linked with the product ID column. Fine. So now what happened? Now the dimension category table can filter the fact table, sales fact table. So the moment when you drop the column category from the table, so what happened? From the dimension category table, what happened? What happened? It gives me the breakdown of the sales. So initially it was showing only this value, 4,56,000. When I dragged and dropped the measure total sales in both these visual, it was showing only 4,56,148. Here also it was showing only one value. The moment when I dropped the category name column from the dimension category table, it gives me the split up automatically. Okay, and next what I do is I'm going to load another table. Let me do one thing. This is the location dimension. I'm going to load another table. In real-time scenario, you'll be working with more than one table, multiple tables will be there. There is some data formatting issue. I'll fix it. Here also you can rename it. This is my dim location dimension. And here the column, the row header is not there in the appropriate place, right? So hence what we do is we just select the transform ribbon, use first row as it is. Yes, I'm done with this. Location key and location name is available here. Right, so for you to understand, right, what, because I loaded couple of tables after I did this, right? So hence to help you to recollect what I did, right? So I just see in both the table I have used the single measure, right? Same measure, total sales. The measure name is total sales. What logic I wrote it here? I just show you one more time because I have a mix of people. Total sales here. Look here. You can see the sum of sales amount, right? Sum of sales amount. That is the output of this one is nothing but your total. So this is what your measure. The moment you drag and drop it in the visual, it will compute the sum of sales. That is how the measures are working. Only when you invoke the measure, it will perform the computation. Now you in both the visual, since you have used the same measure, it gives you the total sales. Along with this, if I drop a text column, categories a text column, if I drop it, what happens? This 4,56,000, right? This is the total sales. The moment when I drop text column, it gives me the breakdown of sales. Okay. Beverages, in beverages category, how much we sold in total. In dairy category, how much we sold in total. That is what we can see it. So what I do is I just move this up so that your category column will appear first and then total sales. The same measure here, if I select the location name and if I drop it here, and if I move this up here, there is some missing value. Okay, let it be there. Probably we will deal with it later. Look here. Earlier, we were seeing only this value, right? We were seeing only this value. The moment I drop this location name from this table, it gives me the breakdown of the sales by location. Got it? So how it is possible? The same measure, I did not use different formulas to give the breakdown of the sales by category or sales by location. I did not use any other formula. I used only one total sales in both the visuals. When I dropped the measure, it was giving me 4,56,000. Along with that, when I use different text columns based on the text column, in this case category, in each category how much sales we made it in total, in each location how much sales we made it in total, it gave me automatically. That is the beauty of Power BI. In Excel, can you do that? You cannot do that. You can do it, but you need to write some formulas for that to give the breakdown, right? But here I don't have to write any additional formulas, right? You drag any other text column along with this measure, it will give you the breakdown of that specific text columns categories, say breakdown by that category. Okay, so this is possible. How it is possible? In these two visuals, I did not specify the DAX formula, anything in relation to category, anything in relation to location name. All I wanted was the total sales. I just dropped the measure. For each row, now we get different values. Though the total sales value is same, but for each row in these two visuals, right, the values are different. Look here, in this case, the Bangalore, you are getting different value. In beverages, you are getting different value. So how do we get different values on each row? That is because of the evaluation context, the environment in which a DAX formula is evaluated, the scenario in which the DAX formula is evaluated. In this case, when I drop the category column, what happened in this case? It has to do the filtering based on the, so how is this possible, the breakdown, first of all, because I did not write any special DAX function, right? Any special DAX one. I have used only one DAX measure where I used the sum function, sum of the totals. Is how it is possible, how it is giving me the breakdown automatically. It is because of the relationship. It is because of the relationship. Look here, here we have the relationship. If I remove the relationship, it will not work, right? And here we have the relation between these two tables, and where is the location? Look here, location also, it has a relationship. So in this table, the location name filters the sales fact table. In this case, the category filters this sales fact table indirectly, okay? Because of model relationship. If you remove the relationship, it will not work. For example, if I just go here, look here, Bangalore 5,532. If I go here and remove the relationship between the dim location and sales fact, it will not give the breakdown. So instead, what it will do is it will repeat the total sales value across the rows. Okay. So now, what is the common column between these two? Location key and location key. Where is the location key? Look here. I just drag this and drop it on this table's location key column. And then if I go back here, if I switch to my report canvas, look here, it gives me the breakdown now. It is because of a relationship. In this case, the location name from your dimension location filters your sales fact table. In this case, the category dimension tables category, right? It is filtering your sales fact table. This is what the environment, right? So with the different environment, the DAX formula, this in the same DAX formula is calculated in different way. Because the category table is filtering this one. In this case, the location name, right? Location table, the dimension table filters the fact table. Because of the different environment, we can see different values in each rows, but end of the total values are same. Got it? So this is what, in simple term, the evaluation context is all about. Okay. There are two types of evaluation context. One is the row context, another one is the filter context. So what is a row context? See, in the case of evaluation context, what happens is before it evaluates the DAX formula, okay, the Power BI applies the evaluation context in two parts. One is the row context, other one is the filter context. See, and if you look at in the internet, right, you will find one more like query context. Okay, let's not worry about this at this moment. Let us focus only on these two things. Okay, so in general, you just think only two contexts. One is the query row context and filter context. And here, right, so there are situations, there are scenarios, both of them can coexist, and they are present for all the formula. Okay. There are two types of evaluation context. One is the row context, three types. Just think at this moment, row context and filter. This one I'll discuss it later. Right? So row context and filter context. There are scenarios where you can find these two contexts can coexist. Okay. So now let us understand what exactly the row context is all about. When you define a calculated column, the DAX creates a row context automatically. For example, if I go here, if I go to my sales fact table, and I don't need these columns. So I'm going to create some new column. So while creating this calculated column, I'm going to create a calculated column here. As part of this, I will show you how to use the logical function switch. Okay. The, let's region, volume, or something like that. Or the location volume. Here, what I'm going to do is I'm going to use the logical function switch. Here, the first argument, right? I'm going to use it as a true here. The expression is true. Okay. And then what I do is I just hold the Alt key and then press enter. It goes to the next line. What I do is I press tab. And for the sake of readability, I'm going to continue typing the command here. So in this case, sales underscore fact. Sorry, in this case, sales fact, right? Yeah, sales fact. And here, let's say the sales amount. If the sales amount is less than or equal to, let's say, here most of the values are less. I say 100. Okay. And then I say the low. The sales is low. Okay. And then the next one is, I'm going to say the same thing, sales fact, and here the sales amount. See, we are creating a column which will hold only the low, medium, high. With that, we can understand those transactions we made low sales. What is the revenue? What is the net margin? Right? If you want to perform that kind of analysis, we are going to create a new column called location volume. In this, I'm going to define the rule. Okay. So here, what I do is here anything is greater than 100, and this is and notation. Look here, if I go back here, I thought of showing it as part of this topic itself, the logical operators. And if you want to combine more than one condition, right, you can use ampersand. So this is nothing but your and, but double ampersand, you need to use it. And instead of double ampersand, if you want to use or, then you can go for this two pipe symbol. There are situations, right? We need to, we need to match the patterns, more than one pattern, right? I want to match. So the channel name matches with this kind of pattern, then it will return true. Okay. See, the same thing, you can write it using OR operator. The channel name is equal to store, or channel name equal to online, or channel name equal to catalog, you can give it. Instead of using multiple or, you can use in. Okay, the in function is very much helpful to, instead of using multiple or, you can specify the logic using in itself. Okay, you can compare more than one value using in operator instead of giving multiple or. So now what I am going to do is the double ampersand I'm going to use. And if the sales amount is greater than 100, and then let's say the sales fact, in this one, the sales amount is, let's say less than or equal to 400 or so, I just call as a medium. Sometimes what will happen if you specify the single quote, for example, instead of the text value, if you use the single quote, it will cause some problem. Okay. And let me see, look here, it got underlined with the red colored thing. Can you see it here? This one, Avinash, right? So this means, right, you're not supposed to use a single quote. Instead, you can use the double quote. These are the basic thing you need to remember. Most of my students, those are beginner, they pose some issues here. Sales fact, and here the sales amount. Yes, it is something like a case, right? Pravat is asked about case. Yes. Even in the case of C language, right? C and those languages, you might have switch function is available, right? Instead of writing the nested if, you can use switch. amount. Here I say anything is greater than 400. I call this a high sales. So next I just type the closure. This is the logical, this is also one of the logical function. Which ones? What are the logical functions? If error, in and all. The switch function, I have used it. The switch function, the syntax is, look here, if you type the switch function, right, followed by this, it is the expression. First argument supposed to be expression, and second one is the value, and then the result. If this condition is true, then assign low in this column. Create a new column by the name of location name. In this column, what you do is you apply this rule. Okay, this rule. If anything less than 100, the sales amount, you call it low volume sales. Okay, medium volume and high volume, something like that. I just press enter. Let's see, if everything goes well. It should not give any error. This is going to be a calculated column in my case now. Location name, right? So this is, so what happened? This is called your calculated column. When you define the calculated column, the DAX creates a row context automatically. Okay. So in this case, what happened? Iteratively, it goes each and every row and checks whether the sales amount is less than or equal to 100. Yes, it is equivalent to 100, low. It is not, right? It is falling between above 100 and less than or equal to 100, hence it is medium. Right, it gives me like this. Each and every row, this gets evaluated. Right, this logic is evaluated row by row. Okay, and then it assigns this one. Okay. For example, if you have, let's say in this case, right, we have 992 rows are there. Okay, if you have a table with 10,000 rows in it, this expression will get evaluated 1,000 times. One for every row in a table, each with a different row context, right? So that is what, right? So it is doing it. So remember that if somebody talks about calculated column or calculate column involves row context. Okay, the row context is associated with the calculated column. So what happens is in the case of row context, it does not propagate the data through relationship automatically. Okay, so in that case, right, if you want to propagate, if you want the propagation to happen manually, right, so you need to use something related and relatable. Anyhow, let's not mix up. At this moment, you understand there are two types of context. One is row context, other one is filter context. In the case of row context, right, so in the case of calculated column, it uses the row context, right? Okay, so what is the 1 second, what is this? I just go back here, the row context. Now you learned how to use a switch function. Okay, yeah. So, and anyhow, I will show you some other examples, so don't worry. So row context and filter context. So row context is nothing but it is a calculated column, the calculation done row by row. Okay, so does that mean can't I perform the row context in a measure? Okay, that we will see it little later. That is also possible. Okay, row context is evaluated whatever an expression iterates over a table. Okay, so in this case, the expression is switch function, right? What are the inside the switch function? We have used the conditions. Those are the expression that iterates over it. Each and every row it iterates. The row context exists in a calculated column or iterating DAX functions. If you use sum x, right? So what will happen is it iterates row by row. The row context exists in a calculated column or iterating DAX function. The classic example is the sum x function. We use sum x function. Sum x, as the name says, right? The function ends with the x. Okay, the function that ends with x is your iterator function, iterating function. So in that case also, what happens is it iterates row by row. Okay. Either a calculated column, or when you use any iterating DAX function, you take any iterating DAX function like sum x, average x, right? So count x, it iterates row by row. Okay, I'm not using, did I use any iterating function here? Nothing, right? Either I create a calculated column. So even in the case of calculated column, it is using the row by row context. Every row it goes and checks if the sale is less than or equal to 100, yes, low. And next it goes here, if the sale is falling between this range, yes, medium. Okay, like row by row, row context exists in a calculator or iterating DAX function. Here I did not use SUMX function. Anyhow, I'll show you little later SUMX function. Okay. See, the row context does not propagate through relationship automatically. This I will explain it later. At this moment, remember these 3 points. If somebody is asking row context, the first thing which should come to your mind is calculated column. Okay. In the case of calculated column, the calculation is done row by row. Okay. The row context is evaluated whenever an expression iterates over a table. So in this case, right, the expressions iterates over a table. The row context exists in a calculated column or iterating DAX function. Row context exists in a calculator or, so I'm going to create one more calculated column and you will see, so that you will be more comfortable with the calculator column. I just delete this one. These are useless columns. Somehow it got in here. So now I just go here. Here I don't have, yeah, I have the list price and quantity. Okay. For example, you don't have this column available at all. Okay. I'm going to create a new column. Or else, yeah, we can use this one also. Okay, anyhow, let it be there. For example, you have something called sales amount, calculator column. Okay, I just use some name. And here what I do is I just take the list price into the quantity. If you multiply, look here, I just typed quantity, you know, the first letter of the quantity Q, automatically displays the drop down thing. You just go and select and this one. Okay. Press enter. What happens is it goes, iterates row by row, and it computes the sales amount for each and every row. This is what your calculator column. So what happened? List price, look here, list price 50 in the first row, and then the quantity is 2. 2 into 50 is 100. And it goes to the second row, and here 50 is there, and then here 4 is there, 50 into 4. The list price is 50 and quantity is 4, 200. It iterates row by row, and then it computes the, it evaluates the expression. It iterates row by row. This is what your expression, the list price into sales, but whatever you mentioned, this is what your expression. It evaluates this expression row by row. Okay, hence it is called row context. Here I did not use any iterating function. Did I use average x, sum x, count x? Nothing, right? Okay, fine. So this is what row context evaluated whenever an expression iterates over a table. So the expression is this one. It iterates over this table. And the third one, the row exists in a row context exists in a calculated column. Yes, it exists in a calculated column. And or iterating DAX function, that we'll see it little later. What is the iterating function, how we can use it? Or what I will do is, okay, I just go and create another calculator column. I'm going to create another column, new column. Here I'm going to use another, okay, so let's know CC1. Here, the sales fact and list price. Here I'm going to use an iterating function, sum x. We discussed about the sum and sum x function. Sum is an aggregator function. Sum x is an iterator function. Iterator function, sum x, the aggregator function. Remember that. If I use sum function, that is doing an aggregation. If I use sum x, because the function ends with x, hence it is an iterator function. Remember this. Because they use different terms in the interview, even when you get selected, when you're working on a project, they'll be using these two terms. That's the reason why I'm telling all these terms. Sorry, here the sales fact table, second one. Since it's an iterating function, which one sum x, the first argument is supposed to be your table name. And second one is your expression. Right, as per this statement, right, iterating DAX function, row context exists with iterating DAX function. Iterating is sum x here. Okay, so will it do the same job as this formula? Will it return the same value? No. So what is happening here? It says the total sales has, this one, 4,56,000. It repeats the same thing across the rows. It's because I have used the sum x to arrive at a new column. So it has given the overall total amount for all the rows. Right? So to arrive each row calculation, we need to apply the Power BI sum x function, right, in a measure, okay, not in a new column. This one is supposed to be used in a measure, not in the calculated column. Okay. Okay. Is there any way can I, here it is not doing the row by, see here also what happens, right? It evaluates the expression row by row, but it evaluates for each row. First row it goes, and then what happens is, let's say you have 92 rows, right? So in the first row itself, when it comes here, the list price and then the quantity it picks up, and then for each and every row it goes, iterated it goes, and then see if you add all these values, right, in this column, if you add all these values, you will get that one. You look here, you have something like 1,80,000, 18,000, so somewhat 2 lakhs. And if you add the rest of the things, right, it will come close to 4 lakhs or so. Okay, so 4,56,000. Okay, that is what we can see, right? So 4,56,000. Already we have seen it here. The total sale is 4,56,000, which means all these values put together 4,56,000. What happens is row by row it iterates, but for each row what happens, right? It goes the first row and then it does the it iterates all the 92 rows, and then it does the sum and then put it here, and again it comes to second row, and again it iterates all the rows, and then it gives me this one. Okay, in this case, what happened? It is not doing the filtering here, right? So here it is not doing the filter here. So is there any way if I can do the filtering here? Is it possible? Calculate expression and then filter one. Will it work? Now it is working fine. Look here, the calculate function does the filtering here. Okay, the calculate function does the filtering here, filter context. It applies the filter context. So here what happens, the sum x function, right? It simply does the total thing. Whereas when I wrap this sum x function inside the calculate function, it is doing the filtering. So you can convert the row context by filter context using the calculate. Simply ignore the context, right? So row by row, I wanted to apply the filter here. Okay, instead of doing the total sums, give me the breakdown for each and everything. So calculate function helps you to transition from row context to filter context. Okay. Got it. So this is the idea here. So next what I will do is so row context iterates the table, but it does not filter it. Like I mentioned here, look here, the row context exists in a iterating DAX function. But here where it is happening, it is not happening, right? It is not happening. It for each and every row, for each and every row, it performs, it values the expression and then it takes the sum, right? So in this case, what happened, it is not doing the filtering here. Hence row context iterates the table, but it does not filter. So with this, you can understand the row context iterates the table, but it does not. But with the help of the calculate functions, we are able to transition from the row context to filter context. Next one is the filter context. So what is a filter context? Filter context is used whenever a measure is calculated. It is nothing but a set of filters applied to the data model before evaluation of your DAX expression being started. Okay, so that is what I have shown you here earlier. The filter context. What is happening? I just dragged and dropped the total sales measure. Look here, the total sales measure. This is the one I created it in front of you. I just dropped this here and then I dropped the same thing into this visual. Okay. So in this case, what happened when I added the location dimension? Okay, this is nothing but location dimension, right? Location dimension to this visual. Power BI, it goes to the sales table or sales column in the fact sales table, sales fact table, and filters the column for each location. And filters the column for each location and it sums the total. Right? So here it applied the filter. Look here, in this case, what I'm look here. So look here, I just show you one thing. To understand it in a better context, location key, I just drop it here. Look here, I just put it here, okay. So Bangalore, what is the location key? BLR. I just go here. And then if you see here, behind the scene, what is happening is the moment when you drag and drop the location name into this visual along with the measure, the total sales, what happens is it goes to the table, fact table. This location key will be, Bangalore will be sent to BLR, will be sent to this sales fact table. So we are looking at this, look here, we are looking at the sales fact table only currently, okay? In the sales fact table, what it does is automatically, it selects only the, first it selects all the Bangalore related records, and then it applies the sum on the sales amount column. It adds all these values. Once it has been done, it prints the total sales here in Bangalore. So what is the total sales? It gives me the breakdown automatically. Okay. In Bangalore, what is the total sales? And then what happens is this location, right? Next record, it goes Chennai. In the location dimension table, next record is Chennai. In Chennai, this is the code. It sends the Chennai code to this sales fact table. Okay, next one is it goes to the next one. And then it applies the sum on this sales amount column. Whatever the total that you get it, that it will be putting it here. So behind the scenes, since we have created the relationship between the location and the dimension location, the fact sales. So in the first, it goes to the dimension table and picks up the first value, BLR. And then for Bangalore, what are the records are there in our sales factor, that will be grouped. And then it apply the sum function. So, and then it tells, hey, in Bangalore, we made 5,532 rupees in total sales. And then it goes to the second row in my location, dimension location table. The second row, Chennai is there. Chennai, group all the records that are relevant to Chennai and then perform the aggregation, sum on the total sales. That is what is happening here. So now what I do is I'm going to clear this filter. Make sure that once you do the testing or so by applying the filter manually here, you need to clear it. Okay, otherwise it will cause some confusion. So that is how it is happening. Okay. So in this case, what happened? The filter context is used. Whereas in the case of calculated column, it evaluated the expression row by row. Sorry, not okay. We will go look at this one. It evaluated this expression row by row. Even in this case, right? I used little bit different expression here. So this expression is evaluated every row. Okay, each and every row it evaluated. Here also it evaluated row by row. Whereas in this case, what happened? Along with the measure, when you drop any dimension column, in this case, the dimension column is location. In this case, the dimension column is category. So based on these scenarios, in this case, or the text column that you drop it along with the measure, it gives me the breakdown automatically. That is because filtering, we create the relationship between category, dimension, fact table, and location, name, and the fact table. We create the relationship. It does the filtering automatically. Filtering. So this filtering is nothing but filter context. The filter context is used whenever this measure is calculated. Okay. So in the filter context used in visualizations. Right. So this filter context can be applied using a visualization and DAX. Okay. So now, okay, one or more applied can be applied using visuals and DAX. Okay. What is the sources of filter? Filter can happen. What is the source of filter? Filter, okay, for your data, okay. Row selection, and then column selection, filter selection, slicer selection in matrix visual based on row and column data fields. DAX formula filters. So these are the different ways the filters are applied on your visual. Okay. So in this case, the beverages, the first row selection, look here, the beverages, this row, in this row, beverages, what is the source? Row level filtering is happening. Here also row level filtering is happening. So that is what row selection. And column selection is here, we don't have the column here. So what I do is I just convert this as a matrix for the sake of convenience. And here also what it is, I'll convert this as a matrix. What I do is, sorry, here the, okay, I remove the location key. Your location key is not required here. Let me just select this one. Okay, even in the case of matrix, so in this situation, what is happening is row-wise filtering is happening. Bangalore, tell me out of the total sales, what is the total sales we made in Bangalore? In Chennai, out of the total sales, how much sales we made? What happens is, right, it slices the Chennai related data out of this total and then it applies the sum on. It gives me the breakdown of Chennai total sales. So row level filter is applied. So now what I do is I just go and select another dimension column. For example, here I'm going to select the category. Okay, I just put the category here. So what happened now? What happened now? So along with this, okay, now what I do is I just remove this. For your sake of understanding, I'll put the location here also. So in Bangalore, total sales is, it's a row level filtering. In Bangalore, what is the total sales out of the 4,56,000? Okay. The moment when I dropped another column, which is nothing but the category here, what happens is, look here, Bangalore 5,532. So it gives me the sales breakdown by location by category. Now what happens is, how many categories are there? 1, 2, 3, 4, 5. In 5 categories, we are selling the products. But if you look at this row total here, then Bangalore 5,000, it is matching with this one. But only difference is it gives me further breakdown within this Bangalore location. Give me the breakdown of sales by category. Each and so out of 5,532, how much total sales we made in beverages, how much total sales we made in dairy, how much total sales. If you add all the things, 530. See, if your manager is asking you, okay, in Bangalore 5,532, so can you give me the breakdown so that you will get to know out of these 4-5 categories, which category we sold more in Bangalore. Now we can say quickly 3,600. But what is happening in the case of, this one, right? So row selection in the matrix usual based on row and column, it applies the filter. So automatically, see in this case, what happened? Bangalore beverages, what is the total? The row and column selection. The row and column selection. For this row and for this column, what is the total sales? For this row, for this column, what is the total sales? For this row, in frozen rows, it applies the filters based on the row and column combination. Some cases, row selection. This is the row selection. Row wise, it filtered. And here, row and column wise, it filtered. Okay, sometimes column selection, right? Column selection. And next one is the filter selection. What is the filter selection? You remember, this is the one we discussed about the difference between slicer and filter. So even in the case of filter, so the filter, so using the filter also, we can do the filtering. See, what are the different ways we can apply the filter? Okay, so these are like, the implicit filter. The moment when you drag and drop any text column along with the measure, it gives you it applies the filtering. So in this case, column row level filtering, in this case, row and column level filtering. Okay, row and column level filtering. In the case of matrix, apart from this, we can use the filters here, right? You can apply this. This is implicit filter, okay? And the filter and slicer also, you can use it. Okay, using the slicer also, I can filter the data, okay? And I can use the DAX formula also to filter. What is the DAX formula? You can use it. You can use a filter function. There is something called filter function is available. And apart from this, you have the calculate function. I have shown you a while back. Calculate function will help you to, apply the filter context explicitly. This is implicitly. It happened implicitly. I want to apply it explicitly. In that kind of situation, the calculate function is in the intro. They'll ask you, what is the implicit filtering and explicit filtering? The explicit filtering, you can do it with the help of the calculate function. The implicit filter is like, row selection, column selection, right? So row and column selection combination, you can do that. The DAX formula is nothing but this thing. So now look at this data and tell me what the initial context for this particular cell. This is the highlighted one. So what is the filter context for this? Is this a row one or column one? Arvind, can you hear me? Am I audible? Can you all please tell me? Sumit? Okay, I'm audible, right? Okay, yeah. So in this case, see this, I highlighted it. So what is the initial filter context for this cell? Oh, okay, unmute. I did not unmute, right? Okay. Yes, yes, Arvind. You can type it also, okay?
Row filter, sir. Row level
filter, right? Very good. Row filter, right? In this, right? So in this case, the initial filter context for this highlighted cell is coming from the rows in the matrix, right? So in this case, Hyderabad. So the right, the row context is the location name is equivalent to Hyderabad, right? That is the one. Location name is equal to Hyderabad. That is what your the initial filter context. The highlighted value has a filter context for the city Hyderabad. Okay. And what is happening behind the scene? This is what is happening. Okay. And even a layman can understand this. Look here, the location name comes from your location dimension. This comes from sales fact table. The what you are seeing here is the fact table. Okay, fact table. This is what your dimension location table. In this call, like I said earlier, it goes in right in this case, in this context, the Hyderabad. A highlighted cell was the Hyderabad. Avinash, this is the one highlighted. I'm talking about this one only. So you right. So here what happens is it first selects Hyderabad related record in this dimension table, and then it passes this location key to this table, and then it filters all the records that are relevant to Hyderabad in your fact table, and then it applies the sum on this column. Okay, you can use sum or you can use average also, you can use count, but in my measure total sales I've used sum function. If you apply sum on this one, it gives a Hyderabad is 7,986. So it's all happening because of the filtering. You have created the relationship. It's all happening because of the relationship that you have created between the tables. Since you have created the relationship between the tables, the filtering is happening. Got it? Okay. The next one is, tell me what is the initial filter context for this table, for this highlighted cell.
Column.
Only column?
Categories.
Category. See, the highlighted cell, what is the category? Row,
Row.
column is daily.
Dairy.
Row and column. So in this case, the location name equal to Hyderabad. For this, what is the total sales in this category diary, which is 5,351.95. This highlighted cell, it shows us 5,351. So it has a filter context for the location Hyderabad and the product category of dairy. Even this is also in the initial filter context. It's all happening automatically, right? Implicit filter. Okay, so DAX, what happens? DAX creates a filter context when you use a pivot table like a matrix. Okay, it uses the fields on rows and columns, and some, right? If you wanted to use some slicer, right, you can use slices and filters also along with this. When you create a slicer, what happens? Even in that case of slicer or filter, the DAX, right, it creates a filter context behind the scene. All right. So apart from this, there is a way to programmatically you can create the filter context using calculate. But we are yet to see the calculate function. We will take a look at it little later. For example, now I'm going to look here. I'm going to introduce another visual here, which is nothing but a slicer. Look here, I'm going to select the slicer here. In this case, okay, the calendar table, I need to do some kind of adjustment to the calendar table here. What I do is min of, oh, I have to change the data type, everything here. Sales table. Here I don't have the order date. That is one problem here. Okay. The order date is there. Yeah, fine. I'm going to the same date dimension, which I created it. date and date. I just create the relationship between these two. Okay, date and order date. Just for the sake of checking the format, everything. Yes, it's a date column and long date format. And if I select the order date and if I see here is date and long date, fine, everything is correct. But only thing is here I have odd coded the value. Instead, what I do is I just use the min of order date, max of order date. Okay, it's done. Here, do I have month? Here, month is not there, right? Okay, month number is there. What I will do is I'm going to create a new column in the calendar table. Yeah, month prefix is there. Okay, fine. So I don't need this one. Month prefix, March, something like this. Because I'm going to use this month name in my slicer. Okay, I just delete. I just go here. So this is the slicer. In this slicer, what I do is I just month prefix. I just put the month prefix here. So some blank is there. We can ignore it at this moment. Okay, and there are some non-matching values are there. So not the year. One second here. Okay, here I removed it and month number, month prefix. Yeah, April, August. These are the right months are there in this one. For example, if I select November month. So what is happening here? November month. And so with the November month, it applied the filter, right? It applied the filter here, right? Fine. So in this case, what happens is the DAX, it creates the filter context, right? Apart from the row and column filter, right? So whatever the selection you made it, accordingly, it filters the data here. For example, you want to see the October, November, September also, right? So based on the selections, whatever you made, right? It filtered this one, right? So the DAX creates the filter context, row and column plus the slicer. Row selection, column selection, in row and column combination, the slicer selection. Okay, it applies the filter. Okay, and apart from this, you can use the filter. I taught you how to apply the filter using the filter pane, right? Okay, fine. Now what I do is I just go here. Up to this, you are clear. So for this highlighted cell, the filter is coming from the row and the filter is coming from the column. So location equal to Hyderabad. For the category dairy, this is what the initial filter context, right? For this highlighted cell. So for this highlighted cell, what is the filter context? That is what I explained you now. I demonstrated in Power BI. Can someone tell me? Let me see how many of you can, how many of you watched it?
Slicer.
See, August month, see here what happens in a row. For this highlighted cell, the row context comes from Bangalore, and then the column context is category ice cream, and then for the month August, right? See in this case what happened? Okay, in this case what happened, right? The initial filter context is not being filtered by an individual row and individual row of the location, right? In fact, the grand total is not filtered from the location, but it does get filtered by the slicer in this report, right? Okay, yes. It is important to note down what you need to note down here. The initial filter context for the highlighted cell is only the slicer month and not the rows and column. Okay. If you don't have the slicer, yes, the filter is coming from rows and column. But in this case, slicer, what you're saying is correct. The highlighted cell here, it shows 200 as a filter context for the, but it has a filter context for the location Bangalore and then product category dairy and the month August. Okay. So this one has already been done. But now when you introduce a slicer, what happens? The filter context is coming from, initial filter context is coming from your month. Slicer, very good. Yes, slicer, right? Yeah. The highlighted cell showing 200 as a filter context for the location Bangalore, where the product of the ice cream and the month is August. This is the initial filter context. Okay. So this is what is happening. So you have fact sales table and then product dimension. So this is your product, eggs, ice cream, shampoo products. This comes from product table. Location comes from location table. Product table, location table, and then month come from the slicer, right? This is the month slicer. So what happens is it filters the fact tables from product, calendar, and so here month equal to August, location equal to Bangalore, ice cream. For this combination of filtering condition, what is the sales? What happens? You have a lot of data here. So you go and select August month data. In that August month, you select only Bangalore data and that too select only the ice cream data records. And then you apply the sum. That is what is happening in simple term. Okay. So then now the question, what do you mean by filter context? How many types of filter contexts are there? What is filter context? It is a type of evaluation context, right? There are two types of evaluation context. Forget about the query context, row context and filter context. There are two types of context, row context and filter context. Okay. The filter context is one of the evaluation context. It's a type of evaluation context. Okay. Okay. And what is applied? Okay. So when we are applying filters on set of the columns or tables in DAX, that is known as filter context. We can say this way also. Applying the filters on the set of values of columns or tables in DAX, that is also known as. And in a DAX version, which one will execute first, filter context or row context? Which one will get?
Row one.
Row.
Filter context applies on top of other contexts, such as row context or query context, right? So this is the important thing. You need to remember it. In the PL 300 exam also, they ask this kind of questions. So which one will see before it evaluates your expression? First, it determines what type of context, whether row context or filter context, right? So in this case, what happens in the matrix, right? First, it applies the filter context, okay? On top of other contexts such as row context or query context, right? So for the first one is this one, the filter context will get executed first. Okay. So next question is, does evaluation context apply before the DAX formula evaluates? Yes. Okay. What is applied as part of the filter context? That is what we discussed, right? The rows, columns, slices, filters, on-screen visuals, calculate functions. What is the difference between evaluation context, filter context? Filter context is a type of evaluation context, right? Something like in the DAX, sorry, in the PL 300 exam, right? They will ask these kind of tricky questions. Implicit and explicit filter context. Difference between implicit and explicit filter context. When in the DAX calculation, you have not declared filters explicitly, so the value will be different based on any dimension field selection. This is the effect of DAX implicit filter context. You did not use any calculate function, or you did not see programmatically, you did not do any filtering. Okay, that is what your implicit filter context. In the case of the classic example is the pivot table, which is nothing but the matrix. The row and column filters are applied automatically, implicit filter. The explicit filter context, what does that? Right? So, for example, you want to perform some calculations. For that, you want to add a filter context explicitly, or you want to remove some records, or you want to add some filtering criteria, or you want to remove some filtering criteria programmatically. See, for example, in this case, I'll just clear this one. Here, what they wanted to see is they wanted to see the total sales in Bangalore to be applied across the rows. So that they want to compare side by side in Chennai and Bangalore, how much sales we made. And you can, with that record, you can find out of the total sales made in each and every city, what is the percentage of contribution by Bangalore? Let's say Bangalore is your base location. Okay, so in that case, I just go and create a new measure. Here I'm going to use a calculate function. I'm going to add a filter, this one, filter context explicitly, programmatically. I'm using the programmatically, I'm doing it. Calculate is a function, the expression is sum of sales amount. Okay. Here, what I do is I'm going to use the filtering condition. For example, location name is equivalent to Bangalore. Here I'm adding a new filter condition. So whatever we did it earlier is the implicit filter. This is one explicit filter. Explicitly, I'm saying it. Okay, I just press enter. Let me see if this one works fine. Single equal sign. Okay. If this condition is true, perform only for Bangalore sales, you just give me that. So now I just drag and drop the Bangalore sales measure, which I created now, along with this one. It is not giving me here. 1 second. I think I should use double equal sign here. Bangalore, spelling correct, right? Sorry. In this location volume, I use the location volume. Sorry, mistake. The condition is wrong here, right? So here, what I do is wait. I want to display the Bangalore sales across the rows. Okay, so this is the one I can see. So let's I started my shop initially in Bangalore. So, and my corporate office in Bangalore, I want to check, in Bangalore sales with other city sales. So 5,000 side by side. So you might be asking this question. This may be sound stupid thing. Here itself, we can compare it. Why we need to. If I ask you, if I go one step further, and if I ask you a question like, what is the percentage of contribution by Bangalore sales compared to other city sales? So 5,332, 5,532 divided by Chennai sales into 100, and 5,532 divided by this one into, what is the percentage, right? In that kind of situation, if you keep this value, right, the constant across the rows, so what will happen is we can, take this value, each and every row value, and divide this one. Okay, 532, 532, it will give you the, it will give you 100%. But here, you forget about this one. Okay, and this one, 532 divided by this one, will give you the percentage. Okay, that we will discuss it when I explain about the all function, the filter functions. Okay, that time we will explain it. So in that kind of situation, this is very much helpful. Okay, fine. So this is the, we have created the filter context explicitly here. Okay, here we have created the filter. Okay, I think I selected something here. Yeah, I mistakenly selected something. Okay. So the explicit filter con means in calculation where specifically adds or removes column filter rules to and from the filter context. In this case, what I did, BLR book look here, this is the measure. In this case, I have explicitly applied the filter by location name equal to Bangalore. Did I apply any explicit filter? So forget about the slicer, okay? Right. So in the case of the matrix, it automatically does the filtering, right? So in the beverages, how much sales we made, in the dairy, how much sales we made. And if you say here, right, the Bangalore sales also displayed here along this, right, column wise. So by default, the row and column filters are applied in the case of matrix. Along with it, if you have any slicer, with the combination of these three, it will apply the filter. But apart from this, I need an explicit filter. I want to add a new filtering condition. Programmatically, I want to filter it. This is implicit filter. Programmatically, I want to filter it. Right? That kind of situation. That kind of thing is called as explicit filter context. Means in calculation. See what kind of calculation? Sum of sales. In this calculation, I have used the Bangalore thing. Okay. And what is a query context? The combination of row and filters create the final query for DAX. That is what your query context. You can define this as a query context. Uses explicitly mentioned row and filter context for DAX, and DAX implicitly creates the query context from that filter and row context. What is applied as part of the filter context? Okay, what is initial rule and what is the difference does it hold with filter context? Okay, and what is the difference between the evaluation context and filter context? Filter, it's already we discussed all the things, right? The evaluation, the filter context, it's a type of evaluation context. Which one? The filter context is a type of evaluation context. There are two types of context, the row context and filter context. Apart from this, you can see something like query context is a combination of row and filters. Okay, that is what your query context. In this case, row selection, columns, and look here products, and here you have something called quarter 1, quarter 2, quarter 3, quarter 4. The row selection, column selection, and then slicer selection, filter selection also. If you have slicer, so these are the set of filters applied to your data model. So end of the day, that is what is happening. The set of filters applied to your data model. So this is one filter, this is another filter, this is another filter. These set of filters applied to your data model. That is what your filter context. Okay. And is it possible to use the filter context along with the row context? Can I use the filter context along with the row context? Say yes or no. Context
Yes,
transition.
yes,
How, Arvind?
yes.
How?
So by using calculate
Very good.
functions, we can use calculate table.
Excellent. Look here. In this case, what I did in the earlier, I showed you, right? The sales fact table, SumX function, I used it here, right? When I simply use the SumX function, it is not doing the filtering, right? It does the total sales, and for each and every row, it computes the total sales. It goes all the records, and it was giving me the total sales. but it was not doing the filtering for each and every row. So the moment when I use the calculate, we notice that the context got changed. What context got changed? From row context to filter context, it got changed because of the calculate function. We explicitly applied the filter on there. Using calculate function, you can add a filter, you can transition row context to filter context, and you can remove the filter also, or you can override the existing filter also. Okay, can we have both the row context with the filter context? Can we transition from a row to filter context? Yes. Can we have both row and filter context together? Very simple. Look here, I just go here. Yeah, instead of that, what I'm going to do is I'm going to create another measure. Commission, I just call the commission. So here what I do is the assumption is all these sales were done by the salespeople. I'm going to use a filter function. The first argument for your SumX function is what? Table name. Instead of the table name, I'm using a function called filter function. Filter because the filter function also returns a table. Okay, then why the hell should I use filter? The advantage of filter is you can apply the filter on your data set. For example, here I have the sales fact table, comma, the sales amount. Those people or those sales amount were achieved 500 and above. Those people, are eligible for. You just think that way, okay? Sales amount, they are eligible for 0.12%, right? So they are eligible 12% on the sales amount as a commission. Here, what is happening? The iterator function, in the case of iterating function, like SumX, average X, count X, the first argument is supposed to be table. But instead of a table, I'm using a filter function. Using the filter function also, we can apply the filter. We can filter the records. All we need is those people or those transactions or the sales values 500 and above, only we are filtering it. The filter function returns a table itself. It's a virtual table. Okay, but this virtual table will have the values matching for this condition only. Those transaction or 500 and above, only thus that record will be returned. It's a virtual table. On top of this table, we are doing this computation. Okay. Here, what is the row? SumX iterating function does the row by row context. You remember the calculated column you use as the row context, or the iterating function also perform the row context. Row by row, it evaluates it performs the computation. Here I just press enter. Let's see, I created a measure here. Instead of creating a calculator, I'm going to create a measure here. So now it is through. Okay, even the case of measure, we can perform row by row iteration using iterating function. And then, for example, if I see the commission here, in Hyderabad, in total commission, right, 64.8. These are the eligible thing, okay? Okay, this is the one, okay? So in this case, what we have done, we have used the row context. Which one? The row context is your sum x. Sum x, the iterating function uses the row context. Along with that, I have used the filter context. You can have the row context with the filter context like this. Okay. To summarize, the filter context filters the data. It does not iterate. Filter context filters the data. That's all. It will not iterate. Whereas the row context iterates the data, but it does not filter. But we can have the combination of these two. Okay, you can transition your row context to filter context. That is possible. And both the row and filter context can coexist. But the filter context cannot iterate and the row context cannot do the filter. It can only iterate. Okay, to summarize the evaluation context, right? So what is the evaluation context? It is nothing but the context that modifies the value of your DAX expression by filtering your data model. That is what we have seen it. There are two types of evaluation context. The one is the row context, the other one is the filter context. So both the row and filter context can coexist. Okay. And the DAX creates the row context automatically whenever we define a calculate column. Okay. And you can also create a row context programmatically. We can also create a row context. How we can create the row context programmatically?
Write a measures.
Measure which function you use it. Iterator function.
Iterate functions.
Sum x function, average x function, count x function performs row by row iteration. So the DAX creates a row context automatically when we define a calculated column. Okay. So we can also create a row context programmatically. Apart from calculated column, is there any way we can create the row context programmatically? Yes, using iterating function, sum x function. I've shown you a while back. Right. So in the measure, look here. In this case, what happened? The commission. It performs the calculations row by row. Okay, sum x iterating function. Okay, good. So if you remember these points, that is enough at this moment. Okay. So next one is this one. I will see it later. Okay. Next, we will jump into the filter function. What the filter functions are available? The calculate function. In the interview, they ask you what are the DAX function that you have used it. You can tell them that you have used all the aggregation function like the sum x, and when you say sum x, what is the difference between these two? Sum is an aggregator function, sum x is an iterator function. But behind the scene, in practice, behind the scene, what is happening is the aggregator function behind the scene, it gets converted into iterator function. It gets translated as the iterator function. The sum is nothing but sum x. When you give sum of sales amount, behind the scene, what the DAX engine does is it converts the sum function to sum x function. And then the first argument, it considers the table name, comma, the sales amount column, whichever column that you want to do aggregation. The sum, see, this is what I'm saying here. This I already discussed. Sum of sales is an aggregator function, right? The sum or average sales. These are all aggregator function. Okay. And with this aggregator function, if I put one extra thing like x, average, yeah, these are all called iterator function. Iterator function, these are your aggregator function, because it aggregates, it sums the values. Okay. Okay, Samasir. So here, sum and sum x, the difference between these two, right? Sum and sum x. Difference between these two are, so when you use sum function, what are behind the scene, it converts the sum x behind the scene. According to you have used only sum of sales, but behind the scene, what it does is it converts the sum x and then it put this is the sales table. In the sales table, sales column, you need to sum it. This is how it converts this one. So the aggregator function behind the scene, it gets converted as a iterator function. This is what I said. So what are the different types of filter functions? The calculate function. The calculate table is also a filter function. Filter is also a filter function. Apart from this, we can use all selected, all except. These are the filter related functions. In addition to that, we have keep filter, remove filter, unselected value. All these things are falls under filter functions category. Okay, they'll ask you the questions like what are the other DAX function that you used it? Sum x, okay. What is the difference between these two? Now you are clear. And what are the other functions? You can say count x, count ax, and count rows, distinct blanked, and right. So count distinct rows. And what else? Right, these are the count family of functions you've used it. Average x, average a function that you use it, and you should know the difference. I explained you to remember the difference between these two with the simple tips, right? You just watch my video. And apart from this, they'll ask you, they expect you whether you worked on a calculate function or not. This is one of the important functions. Okay, if you say, yes, I worked on calculate function. Okay, the calculate was a very simple function, but yet it does the complex things. It's one of the most dynamic function. It helps you to add deeper insights to our reports. Essentially, the calculate function, what it does is, right, it helps us to change the context of your calculation within the measure. Okay, change the context of your calculation within the measure. Okay, and you can add a filter, you can modify the filter, you can evaluate an expression with a modified filter. Okay, so this is a syntax for your calculate. The first one is expression. Look here, very simple one. Here I have used this. Okay, here the Bangalore sales. Look here, the calculate. The first one is an expression. In this case, sum of sales amount. Sum of sales amount. Filter one, filter two. So what is the filter one? Bangalore. Okay, and comma I can use another. The location name is Bangalore, comma the quantity is greater than 10. Okay, so you can add more than one filtering criteria here. Okay, what kind of filters? It can be, the filters can be a Boolean filter, or the filter can be a table filter function, or the filter can be filter modification functions. Okay, so what do you mean by Boolean filter expression? This is the classic example for Boolean filter. If this condition is true, matching to this, right, matching to this condition, right, or if this condition is true, for those set of records, you compute the sales amount. That is your filter, Boolean filter expression. What is the table filter? Table filter, you remember filter function. I have used it, right? That is what you were. And apart from this, we have filter modification function. We have something called all function, all selected, and all selected, keep filter, remove filter. These are all the filter modification functions. This is mandatory and these are optional. Okay, and the calculate function DAX evaluates an expression in a modified filter context. So sum of sales amount, comma, the sales is, sorry, the location is equal to Bangalore. So in this case, what happened? Row and column filter plus the slicer also applied the filter. But even though what happened, this one, right, based on this condition, only it is doing it. This 200 is not arrived based on this row and column. Please remember this. Here, the calculate function, in this case, it evaluated the expression, the sum of sales amount in a modified filter context. This is what the modified filter. We modified the filter context, the implicit filter context, we modified it. There are two parts here. One is the aggregation, that is the mandatory, and the filter. Okay, the calculate function is very similar to the Excel SUMIF. In Excel, we call this as SUMIF function. Okay, this is equivalent to SUMIF function in Excel. Okay, the calculate function. So what we can do with calculate, we can modify the filter context. It can override the already existing filter context with the new one that is been specified in the calculator. Look here, in this case, it has overridden this filter context, right? Okay. and or it modify the filter context. In the filter, if the filter does not exist, it will add new filter context. Okay, to the filter context specified. So look here. The example is this is the one. This is the one. Already I have used here. In this case, the city is equal to Bangalore. I have used, right? Location name equal to Bangalore here. So this is the first argument is mandatory and second one is the optional. Okay, and the option. And what is this one? Is this a Boolean filter or table filter or modified filter function? This is a Boolean filter because this one will return true or false, right? Boolean filter. So you can have more than one Boolean filter. Okay, and okay, here. Okay, 1 second. Now you can have more than one Boolean filter condition like this. United Kingdom, countries United Kingdom, and then in the United Kingdom, those records wherein the quantity is more than 10, you select only that one. Okay. This is Boolean filter. Which one? You can see this is your Boolean filter. This is a Boolean filter. You can have more than one Boolean filter. And also you can have the filter function. Look here, there is a function called filter. What is the difference between Boolean filter and filter function? The filter function returns the table, whereas the Boolean, it will simply, filter that records. Okay, it returns the virtual table. Okay, table filter expression. Okay, in the filter is also an iterator function. Okay, remember this. But there is an exception here because here this function doesn't ends with x, but this is also iterating function. Since the iterating function, since it's an iterating function, the first argument is supposed to be table name and then the condition. And if you measure using calculate contains a modifier like all function, look here, you have the total sales and then the Boolean filter here. And again, you have more than one Boolean filter. In addition to that, you have something called all. So in this case, which one will get evaluated first? The first one, right? This filtering condition, right? So we'll see here we have two Boolean filter. Even though we have a 2 Boolean filter, first this one will get evaluated. First it will filter the quantity is greater than 10, and then it will filter the Hyderabad records. Second, and then this one will get evaluated. This is the order of evaluation. You need to remember it. Especially when you write a calculate function, if you keep this in mind, your query performance will be faster. Supposing in your data set, right, you are selling in multiple locations. You are selling in multiple locations, then there could be chances, right? All the locations you have the quantities more than 10 will be there. And the number of record will also be more. Let's say you have started your retail shop in Hyderabad, recently, maybe 6 months back. You know very well the volume is not high. But the total, all the city put together, your table data volume is 1 million records. But Hyderabad alone, the number of records are less. You know very well because recently you started. In that case, in what order you will define the filtering criteria? This is performance tuning. See, did you understand or not? Okay,
Evaluated fast, location key will be Hyderabad.
Yeah, it should be here, right? You need to
Yeah.
it here,
Yes.
right? And then you need to specify this one. Okay. The innermost, right? The innermost filtering condition will get evaluated first, and then the outside one, and then only this one will get evaluated. You just assume that in a table you have 1 million record. If I ask you to find out the total sales for Hyderabad city, right? And if it is not evaluating the filtering condition, so what will happen? 1 million records, it goes in to the total, sum all the sales. That is waste of time. If it is 1 million, fine. If you have 100 million records, If you blindly sum all the records, 100 million records, and then if you find out, take only the Hyderabad record, what will happen? That is to, let's say, I have given you 10 papers, right? Of the 10 papers, you are, let's say, 6 papers full of, the transaction, the invoice number 10, 100, 200, something like that. And here in this paper, you have Hyderabad related sales. What you will do? Will you do the total of all the things? That's a nonsense thing, right? What you will do, hey, which paper has Hyderabad related? So this is the one. You take this one. That is what the filtering. First, you do, filter the Hyderabad related data. And then what you do is you do the total sales. And then you sum the each and every transaction sales. And then you tell in Hyderabad, this one will be faster, isn't it, Avinash? Instead of adding, instead of summing blindly all the papers, transactions, sales, right? Go to the Hyderabad paper, and then the same thing is happening. It's a filtering. So in this 1 million, 100 million record, take only Hyderabad. And Hyderabad may be, right, you have 100K, only 100K records are there. 1 lakh records are there. So this is 100 million, just 100K transactions are there. First you see, in this case, this is the evaluation order, but still you should know in what order you need to write the Boolean condition also. You know very well that that's the reason the domain knowledge, business knowledge is also very much helpful. First, what you do is here location key is equal to Hyderabad, and then quantity is greater than. Since I know very well, right, in this data set only 100,000 records are related to Hyderabad. But if you say greater than 10, quantity is greater than 10, Hyderabad and other cities also more than 10 would have sold. So that records may comes close to, right, 2 million records. 100,000 is 1 lakh is big, or 2 million is big. This is too big. Quantity is greater than 10 will return more than 1 lakh record. Instead, use your brain and say, hey, Hyderabad, I know very well 100,000 records. Better I will put this condition here, put this condition, so that the innermost Boolean expression will get evaluated first, and then this one will be. So Hyderabad, first filter it with Hyderabad, because Hyderabad, less number of records are. Within that, you apply another filter within Hyderabad, which all transfer we sold it more than 10. For that, you do the total sales. Got it? So, but this is the evaluation order. Okay. But along with these things, right? And if you introduce something called the filter modification function, this is called your filter modification function. This one will get evaluated first. Look here, the filter modification function will get evaluated first. This one will get evaluated first, and then this one will get evaluated, and then this one will get evaluated next. Okay, and then finally this one will get evaluated. So it gives more weightage to this one, the filter modification function. Okay, this is your Boolean filter. This is a filter modification function. And these are your logical qualifier and physical qualifier. That we will see it later. Okay, and here, look here. So you can write it this way also, right? So says your country equal to United Kingdom, and then and ampersand and quantity is greater than 0. So can I write it this way? Can I write it this way? You can specify more than one filter condition in your calculate function. Filter, you can use more than one Boolean filtering or table filtering. But instead of using more than one, can I use and ampersand, right? So only one thing, right? So if you see this one, so that's why to evaluate this one, which query is better, you can look at the logical query plan and see, here also, here in this case only 12 steps are there, but if you see here, the 13 steps are there. And then interpreting this one requires special skills. Okay, so right, that we will see it later. And see now the reason why I put it here is, of these two DAX query, which one is performing well? Both of them gives me the same output, but of these two, which one is better? How do I decide that? By looking at the logical query plan, you can decide. And apart from this, in which one? DAX Studio, you will get this thing. Okay. Apart from this, we have something that's called the formula engine, storage engine, right? So how much time it takes, all the things matters. So how do I create the calculated column measures? The quantity into unit price, right? Total product cost, the quantity into unit cost, the gross margin, the sales amount minus total product cost. These are, you can at the time of entry, you can tell them, right? These are the columns that we have created or measures we have created. These are the KPI, right? Total sales, and then this is my cost of goods sold and gross margin. The sales amount minus the total product cost, that is what your gross margin. Gross margin percent, how will you compute? The sum of sales gross margin, sorry, the gross margin divided by the sales amount. That one will give you the gross margin percentage. So these are the key business questions, right? So you can write a DAX questions by taking up my data set, and then you can, you can do this one. But anyhow, we will look at this one later point in time. Next one is the calculate table. It's already 11:10. So what I would suggest, right? I'm going to wrap up this with this now. So what we will do is tomorrow we will continue. Okay, Thursday we'll continue. Okay, and because Friday I have status calls, tomorrow night we will continue this one. Okay.